This triple integration. We have to solve this integration by converting this problem into spherical coordinate system. In our previous video already we have seen what is spherical coordinate system. It is just like a cylindrical coordinate system, but there is some difference between it. Okay. So see, I will not rewrite the problem since we have an integral in front of you. I will simply write the given region is bounded by here. So these are limits of z. So here z is equal to 0. So you know that z is equal to 0. This is equation of what? XY plane. Okay. Next is z is equal to square root of 4 minus x square minus y square. To remove square root, I will take square of both sides. So that is z square is equal to 4 minus x square minus y square. Let us shift x square minus that minus x square minus y square on this side. So therefore, x square plus y square plus z square is equal to 4. So this is a sphere. This is a sphere having center origin 0, 0, 0 and radius is 2 since 4 is a square of 2. Next we have limits of y. Limits of y are y is equal to plus minus root 4 minus x square. I wrote plus minus because there is plus for upper limit and minus for lower limit. To remove square root again I will take square of both sides, but when you take square, plus or minus doesn't matter, you will always have a positive value. So therefore y square is equal to 4 minus x square by taking square. I will write here. So therefore x square plus y square is equal to 4. So this is circle. This is circle in xy plane. XY plane having radius 2 again, getting a 4. Here also we had got the same radius 2. This is xy plane in we have a circle having center origin. And see here and y is equal, last limits of x which are plus minus 2. Okay, so I will try to draw diagram. Z axis, y axis, x axis. This is z axis, this is y axis and this one is x axis. So we have a sphere having center 0, 0, 0 and radius 2. So it will be like this. Okay, and having radius 2. But I will not draw complete sphere. I will draw just half sphere because bounded below by 0 xy plane. See, we from the region bounded above by a sphere but below by a plane xy plane. So we should consider just upper half of sphere. It has one more name, that is hemisphere. We can call it as hemisphere. Okay. See, after that we had written this circle. So we are getting that circle at the bottom of hemisphere. We have a half sphere like this getting. So see, edge of that hemisphere is nothing but a circle with center origin and radius 2. And limits of x are obviously plus minus 2. If you consider x-axis here 2 and if you go in negative direction of negative axis, we will have minus 2. So that means basically we have this region. Okay. See, we have this hemisphere. So when you have a sphere, it is better to convert the problem in spherical coordinate system so we can easily get the answer. And they have mentioned the same. So let us convert the problem. So I will mention to convert problem or integral in spherical coordinate system. We don't have a space, so I'm writing in this way. We put, you remember what we put in last video we have seen. So we put x is equal to rho sine phi cos theta, y is equal to rho sine phi sine theta, and z is equal to rho cos phi. And see and dx dy dz, there is a particular value for dx dy dz. You remember in last video we had found Jacobian into dr, d rho, d phi, d theta. So that Jacobian I am going to write, that is rho square sine phi d rho, d phi and d theta. Okay, so we have done this substitution. You can make a screenshot of it. After that, we will go further. Let us find limits now. So rho means simply radius. Okay, so here radius is, I should write 0 to 2. Since we have already seen we have got a sphere having radius 2, so that's why I'm writing rho from 0 to 2. What about phi and theta? So let me tell you first what is phi and what is theta. See, if you have three-dimensional figure, suppose point is here, we have some point P. See, if you join the point in this way, okay, then we will have a projection like this on xy plane. There will be some angle between that vector and z axis. So that is nothing but angle phi. And if you take a projection of point in xy plane, there will be some angle between x and that vector. Okay, so that is theta. Getting, suppose this is z axis, this is x axis, and this is y axis. You can easily see. And suppose this is a point where at the top of this plane. Okay, so see, it is making some angle with z axis, positive z axis, that is phi. After that, if you take projection in xy plane, suppose this is a projection in xy plane, it is making some angle with positive x-axis, with this positive x-axis, that is nothing but theta. See, we have to cover hemisphere, na? So we need to think in this way. Okay, I will draw another diagram. Suppose point is here. Okay, so see, actually it should move. This is vertical angle, no? So it should move in this way. It should move in this way to cover a half sphere. Okay, so angle will be 0 to pi by 2. You are getting? After that, I will rotate by complete 360 degree in this way. So that's why we will have a hemisphere. You are getting? We have simply half curve like this. We have simply this curve, and after that we are rotating about 360 degrees. So we will have a hemisphere, entire hemisphere. So theta varies from 0 to 2 pi. So in this way we get the angle and we get the limits. Okay, otherwise if you understand, it's better to understand geometry and produce the limits. Otherwise there are some standard limits for what are limits of hemisphere, what are limits of the region of sphere lies in first octant, or for a complete sphere. So these are limits are fixed. So we have limits in this way. After that, what will I do? We have this complicated expression x square plus y square plus z square. First of all, we will find its value and then we'll go to solve integration. Consider x square plus y square plus z square. So let us put values of x, y, z. So this is rho square sine square phi cos square theta, y after that rho square sine square phi sine square theta plus z is rho cos phi. So after taking square we will have this one. Tell me, from first two terms what can we take common? Rho square. We can take rho square common from just first two terms, as well as we can take sine square phi common. If you take rho square and sine square phi common, we will have cos square theta plus sine square theta, which is 1, plus this last term rho square cos square phi. Tell me what can we take common? We can take rho square common. But if you take rho square common, we will have cos square sine square phi plus cos square phi, which is again 1. So that means value of this expression is simply rho square. So let us start to solve this integration. Okay, I will remove it. It is not required now. See, we are interested in just limits now. We will use the limits and solve the problem. So therefore, I is equal to, okay. So normally we will solve in this way. Inner integral with respect to rho, middle integral with respect to phi, and outer integral with respect to theta. After that, z square is there. What is value of z we had? Rho square. Z means rho square cos square phi. Okay. After that, value of this integration, square root of its value is rho square we found out, getting, and dz dy dx means rho square sine phi d rho d phi and d theta. So let us simplify it. Integration 0 to 2 pi, integration 0 to pi by 2, integration 0 to 2. First of all, we will correct rows. Square root will get cancelled. We will have rho into rho square into rho square. That means total we will have rho raised to 5. Correct? Sine phi we have, and here we have cos square phi, and yes, only that, d rho, d phi and d theta. So I will say it's very simple problem because simply multiplication is there. There is no addition, there is no subtraction, getting, and limits are also independent. That means all limits are constant. So that's why we can take separate integration. It is because only these limits are constant, otherwise it is not possible. So let us do 0 to 2 pi. So these are limits of theta. So that's why d theta into integration 0 to pi by 2. These are limits of phi. So sine phi cos square phi d phi, okay, into this integration 0 to 2 rho raised to phi d rho. Okay, I could take separate integrations. Make a screenshot of it. After that we will go further. Okay, so integration of d theta is theta, all right, 0 to 2 pi. See how to solve this integration, obviously using beta gamma function. I will write the formula. Integration 0 to pi by 2 sine raised to p theta cos raised to q theta d theta is equal to 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. Okay, so this formula we have to use. So let us use it there. So into, what is p? P is 1. What is q? Q is 2. So let us use the formula. Into 1 by 2 beta of p is 1, no? So p plus 1 by 2. 2, yes, 1 simply. Q is 2. 2 plus 1, 3. So it is 3 by 2 into, what is integration of rho raised to 5? It is rho raised to 6 by 6. Rho raised to 6 by 6 with limits 0 to 2. If I put limit here 2 pi minus 0, 2 pi we will have. This is 2 pi. You know how to convert into gamma function. So beta of nm is equal to gamma n gamma m upon gamma n plus m. So this formula I am going to use. Okay. So actually it is not required. So I will remove it. Okay. So let us continue. So this is gamma 1 using that formula, gamma 3 by 2, and the sum of these two is gamma 5 by 2. I am putting 2 raised to 6, that is 64 by 6. If I put 0, we will have 0. See, 2 will get cancelled, pi, okay. Gamma 1 is 1, gamma 3 by 2, gamma 3 by 2. So you know that gamma 5 by 2, that means you can write gamma. See, there is a formula, gamma n is equal to n minus 1 gamma n minus 1. If you use this formula here, so this is 3 by 2 gamma 3 by 2, and this is 2 will get cancelled, and we will have 32 by 3. See, gamma 3 by 2 will get cancelled. So which is equal to, getting, I will simply cancel it, and so this is 64 pi by 3 into 3, 9. So this is required answer. Okay, so you can make a screenshot of it. After that we will stop. Thank you. Bye bye.